All right, hey everybody. This is another PicoCTF binary exploitation. So this one is honestly pretty interesting. It'll teach you about a vulnerability that is, it's concerning that this vulnerability is actually still very much present in software today, and it shouldn't be. So we're given, I decided to try something no one else has before. I made a bot to automatically trade Stonks stocks for me using AI and machine learning. I wouldn't believe you if you told me it's unsecure. We're given vuln.c and we can interact with it using Netcat here, hosted on PicoCTF server. So if we open up vuln.c, we're given a C file here, source code. Interesting, we've got flag buffer, which is 128 in size, 128 blocks. So we got some structs here for Stonks portfolio. So if we scroll down, let's actually find main first, because I like to start there. So we're given a chance to say, okay, welcome to the trading app. What would you like to do? Buy some stocks, view my portfolio. To save time for this video, feel free to explore the code yourself, but let's just say we want to buy some stocks. We go to choice 1. So if response is 1, buy stocks. Okay, let's go up to, let's look at the definition. Here it is. So interesting, we've got a car API buffer, which is the size of flag buffer, which is 128. So that's interesting. Here we can see if we can't open this file API, it's going to say flag file not found, contact an admin. Okay, interesting. So our flag is probably in there. Our flag is probably within the API buffer, that token. So then we do some, we've got some linked list here, and yeah, using AI, whatever. If we scroll down here, this is an interesting piece of code here, which actually I didn't notice at first when I was taking a look at this. I had to do some research on this problem to figure out what was really going on. This is the vulnerable piece of code right here, specifically right here. So what's happening here? This is called a format string vulnerability. And the reason is because when it asks what is your API token, we have a scanf, so we're getting something from the user. We are allowing 300 spaces for a string, and we're going to put user buff into there. Now, here's the vulnerability. We have a printf function without any without any quotes specifying the type and then the variable to pull the data from to print it. We simply just have this. This is a vulnerability because what we can actually do for user buff is if we supply an answer, if we supply input of, for example, %x, %x, or %d or %d, we can actually print stuff from the stack, in real time, during runtime. So that's the danger of not specifying, that, this is a car, so it would be percent, it would be, parentheses percent C, or percent S. That's the danger of just having this. So this is what we can exploit. Okay, so let's go, let's actually open up well, first of all, let's copy this, and let's open up a web shell, and let's see. Okay. Oh yeah, I didn't show my password. Okay. All right. So let's Let's just connect here. Okay. All right, so what would you like to do? We're going to buy, so 1. What is your API token? Now, this is where we can do some exploit. Okay, so literally all we have to do is if we do %x, basically what that's telling us to do is to print stuff from the stack in hexadecimal format. So let's go way up in the stack here, just so that we make sure we get everything. Each %x is like a byte, I'm sure, something like that. But let's just make sure we get all the way up in the stack. Okay. All right. Cool. So we've got some interesting stuff here. Bind stonks with token. This is our token. Well, not really, but it's data from the stack just kind of spat out at us because we were just, this is during runtime. It's not going to make sense, but it's the order of the stack right now. So we know it's in hex, so we can actually copy this and do hex to ASCII. And let's put it in and convert. Okay. So most of it looks like garbage. This is, if you look closely, this is actually our flag. It's Pico backwards. And this is seemingly our flag. Now the problem is that why is it backwards? Well, because we can guess that this program is printing out in little endian format. It's little endian instead of big endian. So little endian is least significant byte first, which is why this is reversed. Yeah, so let's figure out how to format this. So what we can actually do is, let's quit this program. I'm going to open up Python. Let me actually clear the screen first. Yeah. Alright, so we can open up Python in here, and we can actually do, let's just say s equal to our string here. And now let's create a for loop. So the basic idea of what we want to do is we want to we basically just want to, so for each 4 characters, we're going to flip. We're going to reverse it for each 4 sections, for each 4 bytes. Okay, so we're going to do 4, 0, the length of s, and every 4th. And we're going to, oh, sorry, wait a minute. Oh, I'm sorry. Yeah, for x in range 0 to length of s 4, and then we're going to do print. Okay, so now we're going to do, let's do s x plus 3, right? Because we're going to the 4th, character, plus s x plus 2 s x plus 1 plus s x. Okay, what just happened here? Yeah, x. Okay. So, yeah, okay, so just to recap, because, this was something I was confused on a little bit at first. In little endian format, we're basically just taking each 4 bytes and we're flipping them. We're reversing it so that it's in big endian format so that we can view that. Okay, so let's print, or, wait. Yeah, okay. Okay, so now we have our flag, Pico. So let's copy this, and just for the sake of formatting, let's go ahead and get this formatted correctly. Okay, we're missing the end one there, but yeah, so this is what your flag should look like. Not exactly, this part's probably going to be different. But yeah, that's basically how you do that problem. If you want to learn more about format string vulnerabilities, I'll have some resources in the description. There's this vulnerability is a lot more complicated than it seems just from this problem. And yeah, so if you're interested, go ahead and look at that. And yeah, hopefully this helps.